In most action games, the attack action does not occur only once. The characters in these action games can perform several or more actions in a row, such as a combo attack. If so, the question arises as to how to create a continuous motion depending on the number of keystrokes. Today's video is going to find a way with you. Before developing, let's start with the principle of the continuous attack function. Let's take a look at the character animator that will be used today. There is no motion in the default state. The motion of the character's first attack is as follows. Pressing the attack button twice will play the next motion. Likewise, pressing the attack button 3 times will play the last attack motion. When the last attack motion is over, it will return to standby. And, depending on the number of clicks while each animation is playing, it looks like a condition is needed whether the next animation will play or return to the standby state. Now that we have roughly understood the flow of the animation, let's actually add transitions. After adding transitions, the condition for state movement is required. Today's example will use a parameter of integer type. I'm going to name the newly created parameter int attack phase. Let's apply this parameter to the conditions of each transition. The condition required to play the first attack motion will be equal to 1. I'm going to turn off has exit time so that state transitions can be made even if the animation is not finished playing. I will also increase the value of the parameter required for the next state transition by 1. Since there is no motion after the last state, we will set the parameter value to the initial value of 0. It would be nice to end this way, but we also need a transition to return to the standby state. This is because depending on the number of times the button is pressed, the motion needs to return to the default state after playing. Let's set the value of the parameter to 0 so that each state can return to the default state. Looks like the settings are done. Let's check the flow of animation once again through play. Changing the value of the integer parameter to 1 plays the first attack motion. Then change the value of the parameter to 2, and the next attack motion will play. Now if I change the value of the parameter to 3, the last attack motion will play. By changing the parameter's initial value to 0, it will return to the default state. It is also possible to play back up to the second attack motion and then return to the default state. Now it's time to create a function that plays the attack animation sequentially according to the number of times this attack button is pressed. Here we have a question. We need to figure out how to make the code about the sequential transitions of each attack animation. And, depending on the number of times the button is pressed, we have to write code that decides whether to play only the first attack animation or even the second animation. In summary, we need to figure out which animation is playing, and decide whether to play the next animation or not. To find out what animation is playing, I'm going to apply an animation event. Events cannot be added to an imported animation file. And you can't do any modification, such as changing the animation keys. To add an animation event, simply duplicate the animation element and apply it to the animator's state. For now, I've applied the duplicated animation to all attack animation states, so I'll delete the animation I just duplicated. Let's go back to the Animation tab and see each attack animation. Then we'll add an animation event to the last frame of the animation. There is no method or function to associate with the animation event, so there is no action for the event yet. We will add the script containing the method later, and let's put the animation event in the last frame of the other attack animations. Now, let's create a script file so we can use the animation events. I'm going to apply the script I just created to an object with an animator component. Animation events can only use public methods. I'm going to write a debug code to see if the event works correctly when playing the animation. Let's go back to the Animation tab and click on the events in each attack animation. Let's select the public method anim event we just created in the function item. I will select the anim event method from the function item of the remaining attack animation events. Now let's play to see if the animation event works. As each animation state completes, we see that the debug code runs successfully. Now, let's create the code that will control the attack animation in earnest. First, we will create a new script file and then apply it to the game object that controls the movement of the character. Since we are going to control the animation, we will create a variable so that we can get the animator component of the character. Next, in the start method, we will write code that saves the animator component in the character mesh to a variable. Now let's create a new public method so that we can fire an event when the button is pressed. Since we are going to create a continuous motion function of the attack animation based on the number of times the button is pressed, we will create an integer variable named CountAttackClick. Just in case, I will initialize the CountAttackClick variable in the start method. When I click the button, I will add 1 to the countAttackClick variable. Let's create some debug code so we can check the button's behavior. Now I will connect the UI buttons on click event with the method I just created. It is confirmed that the value of the variable increases by 1 each time the button is pressed. Now, let's create a function that plays an attack animation when the button is pressed. As said in the animator's transition, the parameter must have a value of 1 in order to play the first attack motion in the default state. At the same time, the number of times we press the button should be 1. In that case, we need to create the following conditions. To use an animator's integer parameter, we need to use the setInteger command after the animator variable. Then we have to put in the name of the parameter, then we have to put in the desired value. The first attack animation needs to be run, so the value of the parameter should be 1. When the button is pressed, the first attack animation is played. And at the end of the playback, we can see that the animation event has been successfully executed. I will change it as public variable to see the number of clicks of the attack button in the inspector. Next, I will create code that executes the next attack motion according to the current state and the number of clicks of the button, which are checked by the animation event. I'm going to create a separate method for handling animation events in the manager attack script. Let's go back to the event listener script. I'm going to create a variable so we can access the manager attack class. Next, I will write the code to get the manager attack component in the start method. When the animation event fires, the manager attack class's checkAttack phase method will be executed. Now let's use this method to make the animation play sequentially based on the number of attack button clicks. As mentioned earlier, it seems good to first grasp the playback state of the animation in order for the animation to run sequentially. It's not an essential feature, but it's creating conditions for more accurate operation. We will make the animation transition function later, and let's see if it is possible to check the animation state that has finished playing through debug codes. The animator component provides a command called getCurrentAnimatorStateInfo to know the animation state being played. The integer you need to enter after this command is the index of the layer. The animation related to the current attack uses a second layer, so the index number of this layer is 1. We need to check if the animation of a particular state is playing, so let's use the command isName and then enter the name of the state. We will apply a debug code to see if it is possible to check the playing state. Since we use 3 attack motions, we will reuse the code we created earlier. Let's play the game. As a result of running up to the second attack animation, we can see that the animation state that was playing was confirmed. After playing individual or all attack animations, it must return to default state. Let's implement the function to return to the default state in a separate method. There are 2 items to be initialized. The first one is to return the number of clicks of the attack button to 0. Second, we need to set the value of the parameter to 0 to play the default state. Now, if we press the attack button only once, we will make the character attack once and stop. When the animation state is attack 1, if the button has more than 1 click, it will play the next animation, otherwise it will return to the default state. Let's check it out by playing. By clicking the attack button once, you can see that the first attack animation plays and returns to the default state. Now we just need to make the second attack animation run when the button click is executed more than once. Clicking the button twice will trigger the second attack animation. Since there are no conditions after the second animation event fires, we can see the animation state is frozen. The method of the condition is the same, so I will copy and paste the code. Since we need to run the third attack animation after the second attack animation, the number of clicks on the button should be more than twice. So, if this condition is met, we will make the third attack animation run. Just press the button twice and you will see that the second attack animation will play and return to the default state. Press the button 3 times to play the last attack animation. There is no fourth attack animation, so after the third attack animation, we need to revert to the default state. Now let's complete the rest of the conditional statement. While the third attack animation is playing, the number of clicks will be 3 or more. Since there is no next animation after the third attack animation, we will initialize it immediately. If we click 3 or more times, we will see that it goes to the default state after playing the third attack animation. However, unintended problems arise. After the third attack animation has finished playing, it will not switch to the default state. And we can see that the number of button clicks is not initialized, and continues to increase. It seems to be a problem that occurs because the time when the animation event is executed, and when the number of button clicks are checked are different. Let's try 2 methods to solve the problem. The first is adjusting the transition settings. By narrowing the transition interval between the 2 animations, you can avoid missing or delayed execution of animation events. Since the transition to the default state after playing the third attack animation is the problem, let's readjust that transition. Let's temporarily check has exit time so that we can directly input the value of the previous animation's exit time. I set the exit time to 0.8 and the transition duration to 0.2. It depends on the speed and length of the animation, so it's a good idea to change it until the problem is alleviated to some extent. After setting, don't forget to uncheck has exit time. Let's press the button wildly until the same problem occurs. Once the problem does not occur, it is still better to implement another solution just in case. There may be a problem with the click count check, so if the click count rises above the set value, I will make it forcibly initialized. In this example, we will implement automatically switch to the default state when more than 16 times of button clicks. Finally, we are trapped in a bug. When I kept clicking so that the value of the variable was 16 or higher, it went to the default state. This is not a perfect solution to the problem, so it is very important to adjust the values after continuous testing. As you can see in today's example, there are often times when there is no complete fix for a bug in game making. This is an imperfect mitigation, and it is important to users do not get noticed when they are playing the game. That's all for today's video. Thank you. See you next time.